Okay, now we're going to again address whether 3.2u plus 2.7w is equal to 3v. But first, we're going to draw these vectors again and put some numbers on them. So we draw the v vector, we draw the u vector, we draw the w vector. Forget this up here for a minute. Here's a v, here's our w, here's our u. And then we draw a set of coordinate axes and put a scale on those axes. Okay, we can draw our coordinate axes anywhere with any orientation, put a scale on them, and then here we've chosen to use the usual horizontal vertical orientation for our coordinate system, but we could have used one that wasn't in this orientation. Yet we don't want to think too much about that right now. Okay, according to the scale I've marked on the x and on the y axis, the v vector corresponds to moving 3 units in the x direction and 3 units in the y direction. That is, if we're at the initial point, the terminal point will be 3 units across and 3 units up. So we say the v vector is the vector 3, 3. I use pointy parentheses here, unlike the Larson text, which I love the Larson text. I think it's incredible. He uses parentheses. I don't think that's a very good idea. I don't want to do that, so I'm going to use what I call pointy parentheses. You'll see in a minute why I don't like the idea of using just parentheses, although in a little while we'll also start using parentheses. Okay, now the w vector, I just estimated that this distance is about 0.7 from here to here, and this distance is negative 1.5. Well, from here down to here is negative 1.5 in the y direction, so the w vector is 0.7, negative 1.5. And the u vector, it doesn't go very far in this direction, it goes a little ways in this direction. I estimated 0.4 and 3, just looking at how this corresponds to a typical unit and how this corresponds over here. Now, if those are the accurate coordinates, then we can actually do some arithmetic with these vectors. Now, one thing to get us started, let's apply the v vector starting at the point 3, 7. Okay, now this is regular parentheses. Regular parentheses are going to represent the coordinates of a point in the plane. Pointed parentheses are going to represent a vector that moves us from one point to another, and we're going to move from the point 3, 7 using the v vector. Okay, so if v starts at the 3, 7, in other words, if the initial point of our v vector was 3, 7, where would the terminal point be? Well, here's the point 3, 7, and I've moved the v vector up here. I'm allowed to do that. Remember, as long as I don't change the length or direction. That looks like I drew it a little short, but it's still, this is a picture representing what we would get if we did it right. If we do that, we see that the v vector takes us 3 units this way and 3 units this way. If we start at the point 3, 7, then we start at x coordinate 3 and we move 3 units in the x direction. That gets us up to x coordinate 6. If we start at y coordinate 7 and move up 3 units, that gets us to y coordinate 10. So that the v vector, if its initial point is 3, 7, its terminal point will be 6, 10. So the v vector can be thought of as the vector that moves us from here to here. Now there's another way of looking at this. We could say that there's a vector, and the vector 3, 7 moves us from the origin up to the point 3, 7. That should be fairly easy to understand. Okay, and then the v vector moves us from wherever we are 3 units this way and 3 units that way. Well, if we start the v vector here, as we see, we end up at the point 6, 10, and you see I didn't write this correctly. There are too many 3's here, and it's real easy to write an extra one, but that's no excuse. Okay, so this should be the point 6, 10. Okay, the vector 3, 7 moves us 3 units in the x direction, 7 in the y direction. The vector 3, 3 moves us 3 units in the x direction, 3 in the y direction. So the sum of these two vectors, if we do this vector starting at the origin, plus this vector starting at the terminal point of this one. That means starting at the origin we move 3 units in the x direction, then 3 more. So we end up moving 3 plus 3 or 6 units in the x direction. And this moves us 7 units starting at the origin in the y direction. And this moves us another 3, so we end up moving 7 plus 3 or 10 units in the y direction. Okay, so we see then if we assign coordinates to these vectors or components to these vectors, we can represent the addition of two vectors in a very concise and natural way. We just add the x components to get the x component of what we call the resultant vector, and we add the y components to get the y component of the resultant vector. Okay, now, knowing that this is how we're going to add vectors, let's just do a few additions. How about the vector? How about the addition u plus v? Well, u is this, and v is this. So u plus v, 0.4 units this way, 0.3 units this way, gives us 3.4. So we just add the 4 and the 3, we get 3.4, and now we know what that means. Okay, 3 up and 3 up gives us 6 up. Okay, and here's a picture of that. The u vector takes us over 0.4 and up 3, the v vector over 3 and up 3. So if we do the u vector and then the v vector, the vector that goes from here to here, initial point of u to terminal point of v, has to move over 0.4 units and then another 3, 3.4. It has to move up 3 units and then up another 3, 3 plus 3, 6. So we get the vector 3.46. The vector u plus v that takes us from this point to this point has to move over 3.4 and it has to move up 6 units. Okay, well now what about 3 times the v vector? Well, here's a picture of that. Here's a v vector, here's a v vector, here's a v vector. We move over 3 units for every v vector in the x direction. So we're going to move over 3 times 3 or 9 units in the x direction. We move 3 units up for every v vector. So we're going to move 3 times 3 or 9 units up to do the 3v vector. So, and then there's our 3v vector. Let's go ahead and sketch that in here. Okay, now, we made an estimate previously that 3.2u plus 2.7w should equal 3v. Let's see how we did. Now, when I drew these vectors, I didn't draw the v vector quite as steep as I did before. I didn't draw them exactly the same way. So we don't expect to get a really great result here. And we don't get a really great result, but I'm not making excuses. Draw them yourself and see if you can do better. And you probably can, because I didn't do very well here. Okay. 3.2u plus 2.7w is easy to calculate. That's 3.2 times the u vector, 2.7 times the w vector. Multiply through here, we get this. Multiply through here, we get this. And I did these numbers in my head, so maybe I'm off a little bit. Check me. And then we add these up, and we get this. So the 3u plus 2.7w should move us over 3.17, up 5.45. However, the 3v vector moves us over 9, so we missed that by a mile. And up 9, well, we missed that one by, half a mile. So we didn't do very well. So 3.2u plus 2.7w is not equal to 3v. Now again, that's from a previous picture. Here's a picture of 3.2u, 2.7w. Here's 3.2u plus 2.7w. It's not a scale picture, just a schematic picture representing that addition, but you should understand that. And we ask the question now, what multiples of u and w add up to the vector 3v? And we're going to address that question in the next video.